Hello, my name is Ikena Okeke, and I'm here. I'm going to demo my Coursera machine learning project, which is to build a model to predict the electrical energy output of a combined cyclic power plant. So the outcome of this project basically is to reduce the cost of megawatt per hour of power generation, and for this, we have certain features which we're going to use. I'm going to share them here. So we have temperature, which is a key factor in generating power. We have exhaust vacuum, which drives the steam power plant. And we have ambient pressure, which is critical for plant operation. And we have humidity, which impacts the overall performance. And the last column is for the electrical output, which we're trying to predict. So we're trying to predict column E, and we have these four features A to D to help us to predict column E. Okay, so um, since this prediction involves numerical targets and we have multiple features, we're going to be using multiple linear regression as it helps us understand the relationship between input and output. And the output metric model will be root mean squared error, as you know we want to penalize large errors because power companies rely on accurate load forecasting to optimize power generation. Okay, so for our validation strategy, we would be using Google Auto ML to build a model. So here, this is Google Auto ML in Vertex AI, and I've uploaded my data sets as you can see here. And for our validation strategy, we'll be using a fixed validation set to compare the performance of different models. And we're going to split the model into 80% for training, 10% for validation, and 10% for testing. Okay, so I've already gone ahead to train some models, and I'm going to go to training here. Okay, so I have three models that I've trained, and basically the first model that I trained, which is this one. Let's open it up. Um, okay, or basically, well, let me show you how we actually train a model. So training model, you hit new training, or sorry, train new model here. You give a name. You select regression for type. You select Auto ML. I'm going to click continue just to show you what we have here. Give it a name, description, select the target column, which is electrical output, advanced options. So this is where we select 80% for training, 10% for validation, 10% for testing. And yep, so we use this to train our model. And as you can see here, the first one of the models we trained, let me open it up. So for this model, we used all four features, and we got a root mean squared error of 10.6, which is pretty high. For the next model we trained it without relative humidity, and we used only um, sorry, not this one. Without relative humidity, yeah. And we trained it with just temperature, velocity, and atmospheric pressure, and we got a root mean squared error of 7.5, which is still pretty high. And the last model that we trained, we just used temperature um, and exhaust vacuum, and we're able to get a root mean squared error of 4.01. So basically, this is the model which we decided to use after evaluating all three models. So that has kind of like the best performance. Okay, so I'm going to compare the three here so you can see. And yeah, this one has the lowest score. Okay, so we'll be using the model which has training features of just temperature and exhaust vacuum to predict the electrical output. All right, thank you.